In this video, we're going to discuss FRQ 2016 number 1. This was a shared problem for both Calc AB and Calc BC. It's a table problem. Please pause, familiarize yourself with the question, and then we'll get started. Thank you for reading the question. So let's take a look at Part A. So we've got a table of values. Water is being pumped into a tank at a rate modeled by this function. This is from 0 to 8. Water is removed from the tank at the rate modeled by R of t. So since this is R of t, we need to keep in mind that that's being removed. Where R is differentiable and decreasing, selected values of R of t are shown in the table above, and they gave us an initial value of 50,000 liters. Initial values are important. So they always tack those on at the end of the question. You want to make sure that you put a big circle around it, star it, arrow it, whatever, because you're going to use it later in the problem. Part A. Estimate the derivative at 2. So we come up, since this is R and they want R prime of 2, we look here and 2 is between 1 and 3, so we're going to use those values to find our slope, because a derivative is a slope. So 950 minus 1190 over 3 minus 1. Now when we do our units, because it does say indicate units of measure, notice R of t is liters per hour. So we have liters per hour, but since we're doing a derivative, that would be per hour per hour. When we do this calculation, we can discover that that is negative 120 liters per hour squared. Notice this is worth 2 points, 1 point for the answer, 1 point for the units. Part B. Same topic, same idea. Now they want us to use a left Riemann sum with 4 subintervals. So n is 4, indicated in the table to estimate the water removed from the tank during the 8 hours. You're always going to be looking in this sort of problem to see if they want an average. They don't, so we're just doing the Riemann sum. Left Riemann sum, remember, we start with the left and we use all of these terms but not the last term. We need to look at what we're skipping by. We're skipping by 1, we're skipping by 2, we're skipping by 3, then we're skipping back by 2. These are left Riemann rectangles. So let's keep in mind our first rectangle is 1340 times 1 plus 1190 times 2 plus 950 times 3 plus 740 times 2. Notice those two, those two, those two, and those two. Calculate this up and we'll get an answer. Now, they told us earlier that the function was decreasing. If we think about a decreasing function, a left Riemann sum, notice the top left corner of the rectangle touches the curve every time, and that means that we have error that is over, so that would be an overestimate. So we do these calculations, we get 8,050 liters. It's an overestimate since we have a decreasing function. Now let's notice how they assign points. 1 point for the Riemann sum, that would be for the work involved. 1 point for the answer, and then 1 point for the overestimate and y. Make sure that you give that it's a decreasing function. Part C. Same problem. Use your answer from Part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. Well, so we need to figure out, first of all, there was an initial value of 50,000 liters. So we start with 50,000 liters. We're we're going to add to that the amount entering, but then we have to subtract the amount leaving. Well, so remember, R of T, that represents the amount of water that's being removed. So that answer, which in our previous thing was 80/50, so we're subtracting 80/50. Now, we want the amount coming in during the 8-hour periods. Well, that would be the integral from 0 to 8 of the function W of T dt. In this problem, since it's a question number 1, realize that this is a calculator active question. So if it's a calculator active question, remember to integrate with your calculator. You use your math button, and I believe it's math 9. Let's double check that. So turn on our calculator. If we go math 9, then yes, indeed, that's our integral symbol. So math 9, enter it in, get an answer, and then do your calculations. So again, 50,000, integrate 0 to 8 of WT dt, subtract what's going out, gives us our amount. Notice 1 point for the integral, 1 point for the estimate. Part D. From 0 to 8, is there a time when the rate at which the water is pumped into the tank is the same as the rate at which the water is removed from the tank? Explain why or why not. Well, that means that the two must be equal to each other. Well, to prove that they're equal to each other, we could look at what's happening at the far left and what's happening at the far right. And what we're going to try and use is the idea of if the values go from positive to negative, then at some point the value must have been 0, which means they must have been the same. Because if you subtract the two and you get a 0, they were equal to each other. Or it could go the other way around, where it goes from negative to positive, then there must be a 0 to be found. So in our problem, if we do the far left, W of 0 minus R of 0, we get a positive response. When we do W of 8 minus R of 8, we get a negative. And if it goes from positive to negative, then by the intermediate value theorem, that guarantees that there must be a 0. Therefore, they must be the same. Notice 1 point for considering that, 1 point for the answer.